I will now prove a theorem that follows from the definition of a vector space. And this goes like this. It is called the cancellation law for vector addition, and it states that if x, y, and z are vectors in our vector space V, then if x plus z equals y plus z, well then x equals y. And I will now show you the proof. So suppose, by our assumption, that x plus z equals y plus z. Well, by our vector space postulates, we have, there exists a v, we'll call it little v, in big V, our vector space, such that z plus v equals 0. Now this is postulate number 4, that there exists an inverse to every element in our vector space. So we will now start with this. X equals x plus 0. By another one of our postulates, that x plus 0 is always x due to our 0 vector, equals, well 0 is just z plus v. So we have x plus z plus v. But remember, our vector addition is associative, so we can say equals x plus z plus v. Well, x plus z, by our assumption, is just y plus z, right? So then we can say equals y plus z plus v. And I'm just going to bring it down here. Well, y plus z plus v, again, is associative, so we can say equals y plus z plus v. Well, z plus v, again, is just 0. So equals y plus 0. Well, y plus 0 is just y. So by looking at the first term, x, and our last term, y, we have established that x equals y. Again, just finishing our proof. Well, there are also important corollaries that come along with this theorem, and that is such. There is corollary 1. There is a unique 0 vector in our vector space. 0 is unique. Well, this assumption is very simple. We can prove it by contradiction. So, by way of contradiction, suppose there is a 0 prime, and this 0 prime is in our vector space V, but 0 is not equal to 0 prime. Well, by our assumption, x plus 0 equals x, right? And x plus 0 prime equals x. Well, if x, those are the same, so we can say x plus 0 equals x plus 0 prime. But by this theorem, 0 then equals 0 prime. But this means there is only one unique 0. Again, corollary number 2. The inverse to our element x, or every inverse to an element in our vector space is unique. So y is unique. And I'm not going to write this proof, but it's very simple. Just from this, we can assume that there is a y and a y prime in our vector space, such that for another element, x plus y equals 0, and x plus y prime equals 0, you can just set them equal to each other. X plus y prime equals x plus y, and then it looks just like this. Y prime equals y, and then you see that there's a unique inverse to every element. So if every element x in our vector space V has a special and unique inverse, such that they only go together when they add, they form 0.